articulated. The difference is, the first one, it is having the coordinate x, y, z, and it is having the coordinate r, theta, z, and it is having the coordinate r, theta, phi, and this is having coordinates phi 1, phi 2, phi 3, or you can write 3 different angles. It is regarding the coordinates. And the next, regarding, they are also called as LL robots. These are called LRL robots, and these are called LRR robots, and these are called RRR robots. Okay, the second difference. The third difference, the work volume of these robots will be in the form of a rectangle. The work volume of these robots will be rectangle. You know that rectangular shape, okay, and this will be having a cylindrical shape, so that they are called the cylindrical coordinate robot, and they are having a segment of a sphere. They are having a segment of a sphere is this one. It will be segment of a sphere, and it doesn't have the proper shape. It doesn't have the shape at all. And these robots applications are pick and place, along with, see, I am putting dot here. These are the differences: pick and place, machine loading and unloading. And these robots will have these pick and place, machine loading, unloading. They do, along with this, they do simple painting and simple welding. All these you have to write again: pick and place, machine loading and unloading, and additionally simple painting and welding operation. And these robots will do pick and place, machine loading and machine unloading, simple painting, simple welding. Along with that, they will do painting and welding. And these robots will do almost all these works will be done, and along with that, they will be engaged in the assembly and inspection. Assembly and inspection. Okay, these are the 5 important differences I have written here. Along with that, you can write the robot, the sparkle resoluted work volume of this Cartesian coordinate have very good accuracy and repeatability. The mechanical stability of these robots will be very good. And when arm is extended more, the instability will be there in the cylindrical coordinate system, and they doesn't have a proper this one as because of the sparkle resoluted work volume doesn't have the proper shape along the any directions. Okay, and this doesn't have the proper defined work volume. Okay, and these can do good assembly and inspection. All these they can do. So this is about the physical configurations of the robot. So basically, once again, the physical configuration of the robot is physical structure based on this, how the robots can be. And robots, you take the welding, the robot is engaged in the machine welding operation, painting operation, machine loading or unloading operation, whatever the robots you take, all these robots will be falling under these 4 important groups. I am talking about the industrial robot, not the mobile robot. I am not talking about the mobile robot. Mobile robot will be having the legs and the wheels. That will be different. Okay, I am talking about the industrial robot. And these Cartesian coordinate robots are called Cartesian because the work volume generated by these robots will be in the form of a rectangle. The cylindrical coordinate robots are called the cylindrical in structure. Work volume, the work volume generated by these robots will be in the form of cylinder. And the work volume generated by the spherical or polar coordinate systems are a segment of a sphere, so that they are called spherical or polar coordinate systems configurations. And under the last one is articulated robot arm, or simply we can say SCARA, selective components assembly robotic arm. This will be resembles to the human arm. Okay, and we know that the L indicates the prismatic or linear, R indicates the revolute joint. Okay, revolute and the prismatic. And more the revolute joints will be there. It will be having very good flexibility in doing complicated jobs. If it is linear only, it will be telescopic. It doesn't do any the complicated programs or complicated functions cannot be done by using this manipulator. And please remember the definition of the robot also, and where the robots will be useful. And you can write short notes on the robot. If you are going to write short notes on robot, you have to start with the Isaac Asimov. He is a science fictionist and he was writing so many series of stories about the robots in 1932, and that time the robots were not existing. Once after that, it is within a matter of 1 decade, they found more than 12,000 robots in the industries, American industries. Then the Robotic Institute of America, RI, has taken the shape. And according to this, the robot is reprogrammable, multifunctional manipulator. It can perform series of functions like pick and place to complex assembly operation using variable programming. This is about the robot. And kindly do not use your own ways of defining the robot. You should have the reprogrammability and you should have the manipulator. It can perform the series of functions including the pick and place to assembly operations. Any robot which cannot do the pick and place, it is not called robot at all. Especially the robot is meant for the pick and place only in the beginning. Robota means the hard worker. Okay, then the name robot has taken shape, and robotics is the field in which we are going to study the details of the robot. Okay, this is, and the parts of the robot already I have discussed the important parts of the robot, and try to see that you are going to write the proper diagram of the robot. If not possible to write any complicated diagram, kindly write a diagram of this kind. Kindly write the diagram of this kind and you can able to get good marks. And this is called manipulator, and this is called end effector, and this is called wrist. Okay, this is called wrist, and this will be having a connectivity with the controller. Controller will be there, and this controller, and it will be having the drive systems, pneumatic, hydraulic or electrical drives, and it will be having the sensors. Okay, it will be having the sensors, and it will be having the controllers. It will be having the end effector. It will be having the manipulator. These are the things you have to explain them neatly. Okay, this is about this one. Now next, let me try to understand the different end effectors. End effectors are those which are fixed to the wrist of the robot. End effector and wrist, you can write, you can see. Please remember this, end effector and the wrist. Okay, this is important thing which you need to remember. Okay, end effector and the rest. Now let me look at this. What is the wrist is called? The wrist will be having okay, it will be fixed to this. So it can move up and down, and this will be fixed here, and this can move left and right, and it can rotate along its own axis. And this robot wrist have, the robot wrist have 3 degrees of freedom. 3 degrees of freedom, that is called roll, yaw, and pitch. If the robot it is rotating along its own axis, if it is rotating along its own axis, this is called roll. And moving up and down, that is, this one is called pitch. Moving left and right is called yaw. Okay, so please, I am writing here once again. You can see that I am writing the human hand also to make the comparison. Rolling along its own axis is called roll, and up and down, up and down rotation is called pitch, and left and right rotation is called yaw. Okay, if I took the human hand, if I took the human hand, please look at this. I'll be taking the human hand. Okay, you say this is the hand, this is the hand, and this is the wrist. This is the wrist. Okay, this is the hand axis. If along the one axis of the hand, just I will be taking this as an example to prove that, and it will be very useful to you. This will be called roll. If the hand is rotated along the axis of the hand, the wrist is rotated along the axis of the hand, this is wrist. These are the fingers. These are called end effectors in terms of robot. And if it is rotating left and right, it is called yaw. And if it is moved up and down, if it is moved up and down, left and right, up and down is called the pitch. You understood my point, I think. If it is moved up and down, it is pitch. If it is moved left and right, it is called yaw. If it is rotating along its own axis, it will be called as the roll. These are the 3 degrees of freedom the robot wrist will be having. Okay, the robot wrist will be having. For our syllabus, there are no robot end effectors and all these things. Even the drive system also may not be. Now, for the short notes which may be useful to you, explain the different drive systems of robot. explain the different drive systems of the robots. Drives are those things that will be giving a movement to the manipulator. Movement to the manipulator will be by means of the drives only. Okay, the drives may be electric drive, pneumatic drive,